everyone, my name is Wisma Jalal.
I am Jumaida kay JIMLANO.
And I am Ronie Malinis Jr. And we are going to discuss about seed production and nursery operations.
Did you know that a female milkfish can spawn 1.5 and 1.7 million of eggs? And it can even reach up to 5 million eggs. How amazing is that?
Did you ever wondered about how fish breeds are leveled up? It sounds interesting, isn't it?
How do you think fish seeds are produced? Where do you think they come from? Want to know? Let's get ourselves some knowledge.
Hi guys, our topic for this day is all about the seed production and the nursery operation. So the production of marketable fish begins with stocking of prey in the rearing environment. So for them to assure the optimum and the rapid growth to allow the harvest of some farmers in the shortest possible time. So the fish farmers has to obtain the adequate numbers of young fish for them to meet the possible production or their goals. So these possible fish are the wild captures. Stimulation of the conditions necessary for their productions of fish. So meaning the farmers can also spawn in the fish captivities. But however, the egg must hatch, and this very successfully to the prey stage. So the prey stages are the spawning, hatching, and early rearing. So these are like just a stifle chase that a farmer must win. The race course is filled with obstacles. So the example is the psychochemical quality of water that is available in the dissolved oxygen, speed of proper nutritive composition and particle size, and then the low resistance of disease. Good appreciation of all these factors are needed for the successful production of fish. Fish feed in aquaculture. So as cited in the introduction, that fish farming begins in the stocking prey and came from a wild or produced in the farm. So whatever the origins, they are still indispensable. And the mean of obtaining them is influence the farm production. Meaning the prey, if the supplies are erratic, this means if there have interactions between the other farm activities. Supplies are regular, the farm productions may maximize. So the cost of prey can considerably enhance the important factors in overall production costs in any event. So a good supply of prey is essential to the successful fish farming. Your problems are obtaining the sufficient number of eggs, good hatching rates of this egg, and survival and growth of larvae obtained. In nature, there is a very high mortality in these stages, a lot of effort and attention that needed to overcome the difficulties. Practice reproduction and prey production, certain investment in equipment, the infrastructures, the pond, tank, and water supplies. Trained labor is also needed. These costs can be considered or a part of overall production of material.
Now that we know the parameters to be considered before obtaining and producing fish seed, let us now proceed to the discussion on the two methods of seed production. But before that, let me tell you that there are certain species of fish which is not yet possible to understand and control all the stages of their reproduction. And in most cases, this fish includes the brackish water species, of which their biological cycle includes migrating into the different environment, either moving into the sea or moving into the fresh water. Therefore, simulating the conditions needed for natural spawning would only mean a complete change in the environment, because fish in general, for them to be able to be reproduced in the farm, the conditions needed for natural spawning must be closely approximated. That is why the cost for creating a completely marine habitat or freshwater habitat in the midst of brackish situation would in most cases be prohibitive. Now let's talk about the first method employed to obtain a stocking material, which is the collection of seed from the wild. This method is applicable for those species of which their spawning behavior is not well controlled or not well understood, or for those of which the costs for artificial propagation is way too high, or for those of which their fry can be obtained in large quantities. So, two examples of these species are milkfish and shrimps. Milkfish. Milkfish is scientifically called as Chanus chanus. It is found in warm waters of the Red Sea and the Indian and Pacific Oceans, and is one of the most important brackish water species cultured particularly in Southeast Asia. In Africa, it is only found on the east coast. The fish reproduces once or twice a year in coastal marine waters of 25 meters in depth. Each female spawn 1.5 to 1.7 million eggs, and sometimes up to 5 million. The larvae drift to the coastal waters near the estuaries with a temperature of about 23 degrees Celsius, the eggs taking about 24 hours to hatch. Salinity isn't much important, and the fish are captured where phytoplankton is abundant. When the fry achieved 1.3 millimeters in length, the yolk sac is completely absorbed and they began looking for food. At this life stage, their diet is a mixture of blue-green algae and the associated organisms, which are bacteria and protozoans. The diet will change later on. Artificial reproduction has been achieved in the laboratory, but not yet in a large scale, and thus almost all of the milkfish larvae are captured from the wild. Next example species is shrimps. Among the shrimps used in aquaculture, there are two main groups, the Pineidae and the Caridae. The biology and life cycles of these species are different. For example, of the Pineidae, Peneus notialis is widespread and often farmed. Spawning is carried out in the sea, and the female is recognized by well-developed ovaries and coloration. She molts shortly before spawning. The male places a spermatophore on the female theca, which is kept until egg deposition. The various stages of post-egg development occur in the sea. After roughly 3 weeks, the young, termed post-larvae, begin to migrate to estuaries. The next method is the production of seed in the hatchery. A healthy broodstock would mean to produce high quality and high quantity seeds. However, wild-caught broodstocks is much harder than those farm-reared ones in terms of collecting and selecting them. That is why it is important to observe proper precautions in catching and transporting them. So do with the state of maturity, selection of broodfish from catch, acclimatization, collection of buried shrimps and prawns. It is also crucial for both the caring of broodstock, which includes feeding and segregation. Moreover, the broodstock must be able to produce eggs, which means that they have already reached the gonadal maturity. Spawning of fish may also include natural spawning and induced spawning. Induced spawning stimulates ovulation of the fish. It includes inducing natural and artificial hormones to the fish. Hypophysation is also a type of which artificial hormones are induced to the fish. It induced breedings where the fish is bred by administering pituitary gland extract injection. It could be done through stripping or hormonal injection. It can also be homoplastic and heteroplastic administration using fish, mammal, or synthetic hormones and their combinations. Producing high quality and better strains of fish can be achieved through hybridization and selective breeding, of which these methods enables humans to select the highest possible breed for culture market demand. On the other hand, problems associated with seed collection and hatchery production will occur hand in hand, but it is always important to have a sound understanding of the biology of the fish, either to duplicate reproductive conditions on the farm or to know when and where to collect the fish.
So hi everyone, today I'm going to tackle about incubation and hatching. So there are different types of hatching installations like hatching pans, hoppas, jars, troughs, trays, tanks, etc. and the related locations. Suitable sources of water supply in hatcheries. It is important for cleaning or washing. Also, the importance of cleaning water is used for cleaning the eggs in order to prevent the further contaminations. Next, the temperature and flow rate. The temperature is one of the physical factors that determine the success of incubation. Next is the open and closed system, filters and biological conditioning before transport, adhesive and non-adhesive eggs, bacterial and fungal infestations in hatcheries, ultraviolet and antibiotic treatments effect of temperature or salinity regime on hatching time, size at hatching and viability of larvae, grading of larvae, and transport of eggs. Next is the transfer to nursery pan. Transfer of stock to nursery pan require transportations, acclimatization, time of harvest, grading release, and stocking rates. There are three things that consider in transporting of live fish. The first is the physiology of respiration relation to physico-chemical dynamics of transport medium. The second is toxicology of biological waste products. And the third is the action of chemical additives. Toxicology of biological waste products. So it talks about toxic where the fish excrete ammonia. So there are two types of ammonia. Ionized ammonia and unionized ammonia. Unionized ammonia is toxic to fish at very low level, while ionized ammonia, it is relatively harm. During production, ammonia and other nitrogenous waste can be managed with tools such as biological filtration. The last consideration is the action of chemical additives. So there are numerous chemical additives added to the transport water to elevate the several problems associated with the transporting fish in bags. The most common chemical additives added to the transport water is salt, because salt is used to relieve stress associated with maintaining a water balance in the fish. So those are the three things to consider in transporting live fish. Next is the causes of mortality in transportation. So there are 5 causes of mortality. The oxygen starvation, accumulation of toxins, hyperactivity, physical injuries, and disease. So, oxygen starvation is the depletion of dissolved oxygen in ambient water due to respiration and due to oxidation of any organic matter, including excreted waste of the fish by microorganisms. The second one is the accumulation of toxins. Accumulation of free carbon dioxide resulting from respiration and ammonia as excreted end product. So that is the second one. The third one is that hyperactivity. So hyperactivity and stress, this is due to handling and confined space. The fourth one is the physical injury. This is also due to handling during transport and before transport. So next is the conditioning. So spawn, fry, and other fish for a long transportation have to be prepared and conditioned first in order for us to avoid stresses of the fish. So there are the advantages of conditioning. The importance of conditioning is that the fish become used to confined condition. The fish recover from handling effect of capture. The fish recover from minor injury and etc. And the next is the methods of packing and transport. So there are 3 methods of packing and transport. The first one is the transport of fish in bags and buckets. The second one is the transport of fish in 2 systems, which are the open and closed system. In open system, the carriers with or without aeration, oxygenation, and circulation of water. While in sealed airtight carriers with oxygen, container use like earthen pots, cans, wooden tubs, and etc. So the third method is the packing rates in relation to species, size, temperature, duration of transport, means of transport, and nature of containers, climate, and etc. Next is the use of chemicals like anesthetic, antiseptic, antibiotic, and dosages. Chemical control of osmotic pressure, pH, and carbon dioxide, use of congelants for removing suspended or colloidal organic matter, and the last one is the economic of life of fish transport.